All right, so we're going to just do applications of direct inverse variations. Um, you can do this two ways. You can try to write a couple problems with me and then maybe pause and do some by yourself and then come back to the video. Or I'll have the white binder open up on the bookcase by my desk and you can just kind of look at the answers there. But I definitely at some point I would try to do some of these independently. Okay, so the biggest thing is when we're going to figure out indirect and when to use inverse. So when variables are both going in the same direction, not necessarily increasing all the time, but as long as they're moving in the same direction, we're going to use a direct. However, we're going to use inverse when one goes one way and another goes the other way. Again, one could go down, the other one could go up, but obviously inverse would be opposite. So which is nice over here. The orange sheet is all direct variation examples. The white page you glued into your notebook is going to be all inverse variations. So the biggest thing is with these is kind of picking a variable to use. So you can still use, sorry, you can still use x and y, but you can kind of use different variables too. I'll kind of show you how that works. So the sales at a baseball game vary directly with the number of people attending. If the sales for a game are $12,000 and 800 people attended, determine how many people would attend if the sales for $1,500. So the biggest thing is obviously the more people that are going to come, the more money I would get. So since they're both going to be increasing, we know it's going to be a direct variation. So I'm going to use y and x for this first one. So y is going to be my sales, and x will be my people. And I decided this for a couple of reasons. One, the number of people is going to determine my sales. So this is my independent variable. This is my dependent because the sales depend on how many people come. So I'm going to have 12,000 over 800. And I want to know when 15,000 people are going to come. X, and then we can cross multiply, and I would get x to equal 1,000 people. If you guys want, the calculators are in the gray cabinet. You can grab a calculator for some of these because the numbers do get a little bit big. Because when I multiply, I get 12 million, and then I would divide. Okay, number 2. Ounces of medication vary directly. So here, another keyword, vary directly. I didn't say it up here, varies directly. So it'll always tell you really in the problem if it varies directly or indirectly. So the weight of the patient. So I know the medicine would vary the ounces. So we're going to make M be the ounces and varies directly with the output, the weight. Again, we can use x and y. Maybe I'll make this w. Makes a little bit more sense. So we could set this up in if I didn't want to do the ratio, I could set up with my equation. So I know my ounces, so my weight is 120 pounds. So 120, I'm going to look for my K with 3/4 of that. So we're going to solve for K first. So to solve for K, I'm going to divide by 120, divide by 120, and I'm going to do 75 hundredths divided by 120, and I'm going to get K to equal 1 and 1/60. And then I could use my answer here, how many pounds would a 200-pound adult use? So since I'm looking for I know the weight, I'm looking for the ounces, so I can just plug it into my equation, which would be y equals 1 over 160x. So 1 over 160 times 200. And I would get, I need 1 1/4 ounces. Okay. We could also say a decimal for this since it is medicine. Most pharmacists use decimals a little bit better. Okay, so those are the two ways you can do it. You can kind of solve them in however way you want. I'm just going to do proportions because I like that a little easier. I think it's a little less steps, but again, do it any way you want. So the number of shares vary directly. So Kim owns 5 shares and she gives $12. Sometimes it's easy if you want to put a label. How many stocks a share will she raise for $24? And then I'm looking for my Y. So again, we can use equivalent ratios. Ryan likes to use these, so we can do 2. And I know I'm a little bit by 2, so I know I'm going to have 10 shares. Okay. All right, acreage varies directly with the data, with the production bushels of wheat. 20-acre field for 300, so I'm going to do 20 over 300 equals, in a 50-acre field, so since 20 is acres and 50 is acres, I know 50 is going to go over here, and X. This isn't going to be super good, or we can even simplify this. So I know 2, and I know 25, and 30 times 25, and I'm going to get X would be 750 bushels. It's important that since they're word problems, we're writing labels with everything. We'll get points off. Number 5, the income of computer analysts varies directly. Number of hours, so we really know income over the number of hours. So income obviously is your money over 8. Find the constant. So all I'm asking is just to find K. So 256 divided by 32. So my constant variation is 32. So obviously that means I get $32 per hour. That's not too bad of a job. The gallons of water used to take a shower vary directly with the number of minutes in the shower. Again, the longer you're in there, obviously the more water you're going to use, so that makes sense being a direct variation. We're going to find the constant, so I'm going to do 48 over 8, and I would get 6 as my constant. And the label we could do that is 6 gallons per minute. Okay? All right, last couple ones. We're going to do our inverse. Okay? Again, varies. The word problem says it right in there. You just kind of really make sure you read it very well. With a train, so if a train travels between 2 cities in 3 hours at average 65 miles an hour, how long will it take? Average of 78. So obviously I'm going faster, so I should be taking less time. So that's where 1 goes up, my speed goes up, but my time's going to go down. So we're going to set up, remember our ratio is xy equals xy for inverse, so I know 65 times 3 equals 78 times x. So 195 equals 78 y. I should probably use y here. And so I know y would equal 2.5 hours. Again, we could also really be specific here, and we could say 2 hours and 30 minutes. Sometimes they want to be a little bit more specific. Okay, so a company produces laptops. That number of laptops it can sell varies inversely to the price. So obviously the more you can sell, the less it costs you to make because you are buying in bulk. 2,000 laptops can be sold when the price is $2,500. So we're going to have 2,000 times 25. And then we want to know what's going to be the price for 1,000. And then we can do y. And then so I have 1, 2, 3, 4, 5. 1, 2, 3, 6. Okay. Equals my 1,000 y. And then so I know y would equal 5,000 laptops. Okay. I'm going to show you another way to solve these too. We can kind of go back into our equation of, remember, we have y equals k over x, and we can find our k. Oh, I hope you can see that. We can find our k first. So the width of the variable varies inversely with its length. So I know the width is 4. I don't know my k. And we know it's 18. So we got to think about how to solve for this. So we can multiply by 18, and 18 times 4. So k would equal 72. And then I'm just going to use my equation y equals 72x. And since my x is going to be my length, I know I can plug that in. So we're going to have y equals 72 over 8. So y will equal 8. There's no unit here. So we can just, or sorry, not 8, 9, duh. So we can just say 9 units. Sorry, 72 divided by 8 is definitely 9. Again, either method, setting it up and finding k, or just going there. I kind of like this way better, but it's up to you. All right, the workers varies inversely with the time and days it takes to complete. Obviously, the more people you have working should be the less time it takes to complete a project. So 5 people took 24 days. How many workers will be needed so my y here and my 15. So we're going to have 120 equals 15y, and y would equal 8 workers. Again, down here, all we're doing is just finding the constant. So remember, our constant k would equal x times my y from our original equation, which is y equals k over x. So it takes 3 hours to bake a turkey at 300 degrees. I had no idea that. I don't know if that's factual, so maybe it is. So 900 is my k. So we're going to do what would this be? Degrees per hour. No, hours per degrees. Degrees per hour, I would say. Okay. Next one, the cost per person to rent in a cottage in the Outer Banks is inversely proportional to the number of people who share the rent. Again, the more people you have to move into the rental with you, the less cost per person. So again, my k is going to equal the 7 people I have and $42 per person. So 294 per person is what they're going to spend. Okay, and that's your notes. And then you're going to have a homework sheet and also your study guide to finish. All right, I'll talk to you later.